Okay, so gist of the question was what, Richard? Ruchir?
So we have
What was
to
the, hmm.
we have to they'll give a two-dimensional array and we have to select one element and we have to do the sum of these dots of every element in the 2D array except that row and that column. Elements in that
Correct.
row and column.
Yeah. So 3, 1, 2, and 4, 6, 9. So ultimately, our goal is to pick any one element, and
Yes,
if that element is a of xy, we want to find a of xy XOR with every other number
other than those row and column.
other than, yeah. If we fix this, then except this row and this column, we have to pick the center element XOR with this, 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 and find their sum. And we have to find the maximum value of that sum for any number. That is the question.
Yes, sir.
Okay. So ultimately, this should be XORed with every aij, and we should do the summation of that. And we have to find the, and this summation is for every ij, except I should not be equal to x and j should not be equal to y.
Yes,
And we just have to give the answer, what is the max value for this expression, right?
yes, sir.
Okay. So just to elaborate a little more so that I deleted that.
You're told
Yeah,
to use bits.
yeah. So we will come to that. Let's say, so I just want to expand and write that for every number. For 5, what will this value be?
Which values? No? Okay, five into fives are 1 plus fives are 2 plus fives are 6
Yes.
plus fives are 9.
5 XOR 1, 5 XOR 2 plus 5 XOR 2 plus 5 XOR 6 plus 5 XOR 9. So because for 5, we don't have to take this row and this column, rest all 4 numbers are applicable, right?
Yes, sir.
Okay. Let's go to the another one. 5 XOR 9. Okay. Same way, help me write this expression for this 2.
2 2 XOR 3,
Yes, 2 XOR 3,
2 XOR 2,
2 XOR 2,
2 XOR 4,
2 XOR 4,
2 XOR 9.
2 XOR 9. Okay, this is second. Same way, help me write this for this 6.
6 XOR 3,
Yep,
6 XOR 1,
yep,
6 XOR 4,
yep,
6 XOR 6,
yep. Then for 3,
3 XOR 2,
yeah, so you will do 3 XOR 2,
3 XOR 6,
3 XOR 6,
3 XOR 6,
3 XOR 6,
3 XOR 9,
3 XOR 9. And for 2,
2, sir,
sorry, for 1, center 1,
1 XOR 5,
1 XOR 5,
1 XOR 6, 1 XOR 4,
4.
1 XOR 9.
Okay. Then for 2, one more we will write only for 2, and then we will
Okay.
quickly take a look at the
So
approach wise. Yeah.
2 XOR 5,
2 XOR 5,
2 XOR 2,
2 XOR 2,
2 XOR 4,
2 XOR 4,
2 XOR 6.
2 XOR 6. So basically, out of all these values, the max is the ultimate goal to find, correct?
Yes, sir.
Yeah. Now, the point is, if we want to find XOR of a number with other number, then we want to do the summation. If I just pick one expression out of all these expressions we wrote, imagine if I pick some expression here, let me pick the first one. We want to find out what will be the value of 5 XOR with different numbers. We are XORing 5 with numbers 1, 2, 6, and 9. Is that correct?
Yes, sir.
And this summation we are interested in finding. Now, what we can do is we can look at the binary form of 5. 5's binary form is 0, 1, 0, 1. Is that fair?
Sir?
I've written it as
Yes,
4-bit
sir. Yes, sir.
binary
Yes,
number.
sir.
Yeah.
Yes, sir.
1 as a 4-bit binary number will be 0, 0,
0, 0,
0,
0.
1. 2 will be
0, 1, 0, 0, 1, 0.
0, 0, 1, 0. 6 will be
0,
0,
1,
1,
1, 0. 1,
1,
0.
0. And 9 will be
1001.
1001. Okay. Now what we actually will try to do is, let's look at 0th bit of 5. What is 0th bit of 5?
One set.
1. Now this is set bit. If you are
Yes,
doing
sir.
XOR of 5 with 1, 2, 6, 9, this bit will remain set only if you pick the numbers whose this bit is
Two, 2 and 6. Okay.
2 and 6.
Not
Whose
not
this
set.
bit is not set.
Not set.
Okay. So you are counting how many numbers have 0th bit as not set. So how many numbers are there whose 0th bit is not set?
2.
Two such numbers. Okay. So we are counting that two such numbers are there and they are contributing to 0th bit. So we will do, even if you would have done XOR of all these numbers, if you do XOR of 5 with 2 and 6, 0th bit position will give you 2 to the power 0 contribution, right?
Yes, sir.
That means you will get
Sir.
two ones in the final sum.
Yes, sir.
Okay. Second, for first bit, let's take a look at the same thing. This bit is 0. Now you have to find how many numbers have this bit as 1. So this has this bit as 1. This has. How many total numbers have this bit as 1?
2, sir.
Two numbers. So those two numbers, 2 and 5, if you do XOR, those two numbers will result into a value 2 power 1.
Yes, sir.
Okay. Then same way, let's go to second bit. What is second bit of 5?
Second bit. One set.
1 set. How many numbers have second bit as unset out of
3
all four?
numbers.
Three
3
numbers.
numbers.
Those three will give you 2 to the power 2 contribution, right?
Yes, sir.
And for third bit,
Uh, so yeah, it is not set, sir. One, it is not.
yeah.
Oh,
In this, it is not
one.
set. Only one number has this bit set.
Yes.
So one number will
1
contribute to 2 power
2 cube.
3. Okay, so this 2 into 1, this is 2. This is 2 into 2 is 4. This is 3 into 4, that is 12. And this is 2 power 3 is 8. So overall, the summation, if you do 5 XOR all these numbers,
26.
summation will turn out to be 26.
26.
Right? So this is how we have been able to calculate by just using the bit patterns of different numbers.
Yes, sir.
Okay, now the goal is basically how do we actually go and optimize it. Now think about this. In this matrix, I want to remember three pieces of information in total. First of all, I want to know how many total numbers are there. I will say total numbers with any bit position as set. Okay, total numbers with a bit position as set. 0th bit, first bit, second bit, third bit.
Yes.
In this matrix, let's do the counting. Does 5 have 0th bit set?
No, sir.
5 doesn't have. Oh, 5 has 0th
Okay.
bit
Oh,
set.
has. Okay. Yes, sir.
Has. Yeah. This is set bit we are counting. That is why I wrote
Okay.
TS. Okay, 5 has. Does 2 have?
Does no, sir.
No. 6 has?
No, sir.
Okay. Roughly, can I say we are actually 0th bit is all odd numbers will have 0th bit
Yes,
set.
sir.
How many odd numbers are there in this array?
1, 2, 4, sir.
4. 5, 1, 3, and 9. So 4 numbers have 0th bit set. Same way, how many numbers have first bit set in total?
First bit set. First bit.
First bit is 2 as a count in that.
6, sir.
Yeah, 2
2,
also
6,
has
3. Yes, sir.
1, 2,
6,
3
3, sir.
has,
Yes, sir.
2 has.
That's
4
all.
doesn't have, this 6 has.
6, sir. 4.
4 doesn't have, right? Second bit, first bit
No,
set.
count is 4. I'm saying count is 4.
5, count is 5. I have ticked them with green, you see.
Oh, okay, okay. Nice. Yeah.
So total how many numbers?
5.
5 numbers. So we have 5 numbers whose first bit is set. This is in total in entire matrix.
4.
Okay,
5,
how many numbers have second bit set?
5, 4, 6.
Yeah, 5 has it, 4 has it, 6 has it, 6 has it. So
4.
4 numbers. What
Yeah.
about 3?
3 doesn't have.
3 doesn't have. So only 4 numbers have it. Okay, let's write. And what about third bit?
9.
Only 9
Oh,
has. So
Yes,
only
sir.
one number has third bit set. So we have counted total set bits here, right?
Yes, sir.
Now let's do the similar thing in row also. Every row number 0, how many numbers have 0th bit set? Row
Yes, sir.
1, how many set? Row 2, how many set? There are only 3 rows, so 0, 1, 2. In row 0, tell me how many numbers have 0th bit set?
In row 0, 0 it will check. One, sir.
Only one number, yes. In row 1, how many numbers have 0th
2,
bit
sir.
set? Two
Yes, sir.
numbers. In row 2,
1, sir.
only one number. Okay, same way, let's go to first bit. Row 0 has how many numbers as first bit set?
Rows 1, sir. Okay, sir.
First bit
Row
set.
0 first.
Yeah,
Okay.
row 0 again.
2, sir. 2 and 6.
2 and 6. What about
2.
second? 2 and 3.
Yes, sir.
Okay, third.
4, 6. 4 and 6.
How come 4 has
How
one
sir,
first
it
bit
is
set?
used, sir. No, sir.
Only 6.
Only 6.
Only. Okay. Okay, then tell me in second bit position. 0th row has how
Sir,
many numbers with second bit position?
5 and 6.
5 and
5
6,
and 6.
2. Next,
0, sir.
0. No one has second bit set. Third one,
4 and 6.
4
2.
and 6, so 2. Okay, third bit, can I
0,
directly
0
put
and
0, 0, 1?
1. Yes, sir.
Okay, so we row wise we got the count. This count will be helpful when we exclude a row and a column, because we will be able to strike out those numbers straightforward,
Yes, sir.
right? So same
Yes,
information
sir.
we have to maintain at column level also. So let me erase this part. Let's just build one more part. Then I think we will be able to visualize solution. In column 0, set bits. In column 1, set bits. In column 2, set bits. Okay. So tell me in 0th column, how many numbers have 0th bit set?
0, 2, sir. 5 and 2.
2 numbers, fair. Same way, column 1, how many have 0th bit set?
1. Only 1.
Next,
9.
9, only 1. Okay. Same way, let's talk about first bit having a contribution of 2 in this column.
Oh, 2, sir.
Column 0,
First, okay, good. First bit 3 and only 3, sir.
only 3. So 1. Second column, column 1,
Oh, first bit
first bit. That
2,
means 2's contribution.
2 and 6.
Yeah, 2 and 6. So 2 numbers. Then column second,
2 and 6.
2 and 6, 2. Okay. Let's go to second bit column wise. 0th column,
4, 2, sir.
2, 4 and 5.
And
Okay. First column,
only 6, 1.
only 6, 1. Second column,
6, only 6, 1.
okay. Third,
0, 0, 1.
0. Yeah, 0th column,
Mm.
nobody has third bit set.
Yes, sir.
So this information you got now, correct?
Yes, sir.
Now using this information, let's see how we can find the XOR answer easily. For this 5 we want the answer. That means we are talking about 0's answer. So for this 5 we wanted, 5 will give what XOR value. So 5 is 0, 1, 0, 1. Okay, so let's look at the rightmost bit. This bit is, yeah, this is
First
5.
0.
This is
Okay,
0th
0th
bit.
bit.
Okay,
Yes,
and
sir.
this is 5. Now, for this 5, you want to know out of these numbers, how many numbers have 0th bit as unset?
Uh,
Is that correct?
Total number of, yes, sir.
So how will you get that?
Total number of 0th bit sets minus sets of columns minus set of that column and minus set of that row plus set of that digit.
Awesome. Yeah, so you are saying, so now you want total. How many numbers have this bit as unset?
Yes, sir. 4.
Unset.
Eight.
If total set is
Okay.
known to you, total unset, how will you know? Total unset will be R cross C minus total set for any bit position,
Okay, yes, sir.
right?
Yes, sir.
Okay, same way in now you want to subtract, you want to miss out these numbers and these numbers, and you want to care about rest of the numbers.
Okay. Uh,
Is that derivable from these pieces
yes,
of
sir.
information?
Row length minus number of sets.
Very nice. Yes, row length minus number of set bits there will give you how many numbers have 0th. So since here we are talking about 0th row, in 0th row we know in 0th row one number had 0th bit set, so two numbers will have that bit unset like that.
Yes,
Correct?
sir. Yes,
Yeah.
sir.
So it is all a matter of now finding out basically from overall matrix subtracting these number and these numbers answer, and
Yes,
you will
sir.
get the remaining.
Yes, sir.
Yeah. So it is all about building that answer.
So here we won't use that uh, prefix sum of
Not
submatrix.
required. No, prefix sum is not
Okay.
required. It is just a
Okay.
pre-computation. So basically, pre-computing this total row wise, column wise. Once you have pre-computed this, using this
No,
in
sir.
const.
I have done like I have taken a 3D array and a, it will it will contain 30. Each element will contain 30.
Correct.
In 2D array, each element will contain 30 elements. So in the 30 sets
I see.
for five, like five is 0 0 0 0, like the
Correct.
last four.
See
Yeah,
here
and
also. Wait. 2D array I can understand, but why 3D array? See, this is the 1D array, but this is 2D array. I have drawn it up to 4 bits. You would have drawn what you are talking about is your row array. Row array was total number of rows into 30 bits. Is that right?
yes, sir.
Then column array, column set bits is total number of columns into 30.
Uh, no, sir. You remember submatrix sum problem, no, sir?
Correct.
No, for like that only I added sets of
Understood.
things, sir.
Understood. Got it. Got it. Yeah, you can do that way also. Yeah, you can do
But
that way
still,
also. Yeah. So that way, basically, yeah, what aggregate I have is in row, I have aggregate. Basically, you are computing that through submatrix sum.
yes, sir.
Understood. Understood. Yeah, that will require 3D matrix, of course. But if you go with
But
this approach, you do not require 3D matrix.
okay, I didn't get the answer that way, sir.
No, that
But
also
I'm
should
little,
work. Maybe you would have made some
yeah,
mistake somewhere
yes, sir.
where thing would have been better. But is this logic clear?
Yes, sir.
How using two 2D matrices and one 1D array
Uh,
of this 1D array will also be of size 30 only.
okay, sir. Understood.
Yeah.
I'll try.
Yeah, you can give it a try. And yeah, if you need help with your that prefix sum code, then you can drop the query in the group. I can take a look at. Ideally, your prefix sum should also get accepted. If
Okay.
yeah, because ultimately what you are computing is you are computing a prefix sum as r cross c into 30. That is your 3D array, right?
Yes, sir.
And if I look at the constraints in the question, your r cross c can be 10 power 6. Okay, so it is 10 power 6 into 30. That will make it that 3
10%.
into 10 power 7.
Yes, sir.
Yeah, so basically an additional factor of 30 is coming into picture. Here, okay, here we are actually losing one C factor if you really see. Actually, here R cross C may
Seven.
either C goes away and you compute RS,
Okay,
or
okay.
R goes away and you compute this. So basically one factor is reducing. So if R
Okay.
and C both are 1000 cross 1000, or if R is 2 and this is 10 power 5, or this is 10 power 5 into another one is 2, then there may be a corner case that might be giving you TLE. Yeah.
Yes, sir.
But you can share your code. I can take a look at that and respond back if there is a way to kind of get it accepted. Though tight
Okay, sir.
time bounds are very tight with 10 power 7.
Yes.
Yeah. So,
I'll try.
okay.
Thank you, sir.
Yeah. Most welcome.